Cool, thanks. Yeah, thanks for the shout out to JavaScript Air. It actually isn't happening right now. For the foreseeable future, we won't have any episodes, but maybe one day I'll resurrect it. Yeah, today we're going to be talking about faster JavaScript with SliceJS. Sorry, one second. So this is a bunch of information about me that's might be interesting. My slides are at kcd.im/faster-js. And yeah, if you want to, all these things are linked if you're interested in what those are. So what we're going to be talking about is very work in progress, and it's closed source right now. I'm still working out some things. I want to make sure that it's ready for when people actually care. And I'm going to give a lot of ideas of what could be. I'm not going to be like, none of this is production ready. It's not actually been tested in any real applications yet. There are a lot of unit tests for it though. Yeah, it's going to be really cool though. I think it'll maybe bend your mind a little bit. So my first question, I want people to respond in Slack. Learning existing code, what's the best way, or maybe not even the best way, what are some of the ways that you've learned existing code bases? I'm going to pull this out really quick and put, while people are asking that. So what do we have? Anybody? Good ways to learn code bases. There are none. There are no ways to learn code bases. That's what I'm learning from Slack right now. Maybe people are talking in general. Here we go. Oh, there's a little delay. Well, that makes the interactivity piece of this a little difficult. There we go. Got a couple people. Good ways to learn code bases. Yeah, looking at the test suite. Yeah, both Charles and Den Teppel. Mind maps. I don't know what a mind map is, but yeah, demos in the documentation, just reading the code, looking at the file structure, having a good README, documentation. Has anybody ever had like a system diagram before for your code? Having to, here, I'm going to pull this over here actually. There we go. Yeah, email the developer. That's nice. Yeah, bang head on table. Yeah, so there are a couple of different ways. Yeah, like there's system diagram. Those are all right because like it gives you kind of a holistic view, but at the same time it's a little bit limited because often the diagram is out like way outdated or something. Having a screencast is really useful because it like somebody can kind of walk you through the actual code and show you different pieces, but those fall out of date really quickly too. Code bases evolve over time, and one-on-one walkthrough is really great because then somebody can really show you the pieces. It's definitely going to be up to date. But the problem that you come with there is how much time do people have to bring people up to speed on the code base? And I think this is what most people do, is some sort of, yeah, like pair programming. Somebody mentioned in Slack. Yeah, it's like, it's great, but people don't have all the time in the world to do that. And certainly if you have a code base that's like 100,000 lines long, good luck with your walkthrough. So the best way is to write it from scratch, right? To start all over, clean slate, totally from scratch. That would be the best way to learn the existing code base. And what would be even better is if like the person who wrote the code the first time was there sitting with you writing it from scratch. That would be awesome. The problem is that doesn't scale very well because, like, you know, we thought a one-on-one walkthrough is a little tricky. Writing it from scratch, like, that's not going to happen. So what if the computer could do that for us? That's my question to you. What if the computer could rewrite our code base from scratch so that we could learn the code base? Well, that is something that SliceJS has the potential of doing. So let's talk about this a little bit. So here we have this module. It's exporting two utilities, deep freeze and clone. And deep freeze just does an object.freeze recursively, recursively through an object and its properties. And then clone is this utility that will do a deep copy of objects. So if you were to look at this, even like there's an ESLint comment here to bump up the complexity and the max depth rules because this is a complex function. So a cyclomatic complexity of 11, that's high. I don't know if you know of cyclomatic complexity, but go look it up on Wikipedia. It's kind of interesting, but it basically means there are 11 totally different code paths that this could take with all the if statements and the different branches of direction that this code could take based off of the input. And it's 39 lines long. A nesting of 6 layers down, that's where we get this pyramid looking thing. All of those things add up to kind of a complex looking code. So in addition to that, there's also like within the same file, there's another function. There could be several functions, and you have no way of knowing without actually looking through the code which one of those functions is relevant, or if any of them are relevant at all. And so learning a module or learning the whole file can take a while. If we were to try and learn this, we could probably learn everything about this in about 10 minutes. And like imagine that being scaled out to your entire code base. It takes a while. I think we're all pretty familiar with how long or how much effort it takes to scale a code base. So this is where SliceJS comes in. It allows you to learn the one piece at a time in a really easy way. So first off, you need to understand that SliceJS takes 2 inputs. It takes the original source code, so that module that we had, and a code coverage report. And let's just take a quick step back and look at what a code coverage report is. So this is, if you've seen these before, it's probably because you use Istanbul. But this is a report based off of code coverage that was generated by Istanbul. And code coverage is a metric that tells you how much of your code is being run by your tests. And so here we have these 2 modules, math and utils, and this coverage is actually being generated for this project, coverage example. And we have a math and utils module here. The math one is pretty simple, and we'll look at that one first. It's exporting add, subtract, divide, and multiply, and they're pretty basic functions. And if we look at the tests, we'll see that the tests are actually only importing add and multiply, and they're just calling those functions once each. And so if we look at the coverage report, what we're going to see is add is being run once, and so we see that 1x next to this statement that was run one time, and multiply is being run one time. But divide and subtract, the function itself is never called, and this line itself is never run. That's why we're getting those 2 red lines there. And so that's a kind of a simple example, but if we look at our utils, things get a little bit more interesting here. So this deep freeze function is never called. Let's go ahead and take a look at that test here. Here we're just importing clone, so that's why deep utils is red, or deep freeze is red. And then in our test, we're calling clone 3 times with 3 different inputs. So nothing, a string, and an object. And so here we get, if we pass in nothing, that item is going to be nothing, and so we're going to return right there. In the other 2 cases, or let's see, 2 cases where we are calling this function, it's going to skip over that, and we're going to run through this. And so basically, like you can see through here that like these lines were never run, this line was never run. And if we really like thought hard about this, if this was the only use case or if these were the only use cases we ever cared about in our application, we only cared about calling clone with nothing or with a string or with a simple object like this, then we could actually remove these lines of code entirely, all of these red lines. We could remove this function entirely, and we'd wind up with a function that was simpler, but actually worked for our use cases still. Because those lines were never run anyway. Why do we even have them? They're to cover edge cases that we don't actually need. And so let's take a step back a little bit further and let's kind of build on this concept and slowly build use cases to what our like ultimate learning experience would be like. So Let's start with this. We'll start with importing clone and just calling it with nothing. So if we were to do that and then get a coverage report and then remove all the lines that were never run, what we'd wind up with is this really simple module. So we totally get rid of deep freeze, we get rid of all the logic inside of here, and we just return the item. We return what we're given. And yeah, so that's really nice, going from, I think it was actually 39 lines down to 1, and a cyclomatic complexity down to 1, and nesting, there's no nesting. Yeah, so that's considerably easier to learn, but it's still not like covering all of our use cases. So let's add another use case and see how the slice changes over time. So if you think about this, this is like us writing the module using test-driven development. So we start with one use case, we add another use case, and we add the code for that. Then we add another use case and add the code for that. So here's our next use case, is passing a string, and we'll add the code that's responsible for that. Now, for us, it's a little bit contrived because the ultimate like clone example is going to have this early exit thing here. And if you look at this, like this could be simplified just down to return item. But bear with me for a little bit. This will make a little bit more sense, hopefully soon. So let's add another use case. We're going to pass a simple object. And now we're going to add this code to satisfy that new requirement, that new use case. And so this is considerably easier to learn. We can skip over this, we can skip over that. We know, we've already seen that, we know what that is. We just care about the stuff that was added. And so this is like you're sitting down with a coworker and they say, okay, now we need to add this use case. They type out some stuff, and then you can talk about what these things are all, what these pieces are for. And so you can know, okay, so these added lines are only relevant because we're adding this new use case, and it makes it a lot easier to learn this code. We'll go one more with an object that has an array, and now we're doing a couple more interesting things. And so over time, you build up the code base just using this this kind of use case based driven development, I guess, to ultimately build up the full code base. And this is something that SliceJS is actually totally capable of doing. And actually all of these code examples were generated by SliceJS. So I have this little app here that uses SliceJS. And so we have our code to slice, that's that module that we were just looking at. And we have our use cases right here. So we're going to use the utils, we're going to get clone from our module, and then we can call it in any way that we want. So here, if we call it with nothing, we get item. And now if we call it with hey, we're going to get a return of item. So actually things are a little bit, I kind of skipped over something, and I'll explain this a little bit later, but just kind of gloss over that'll be important a little later. So we only have the string hey. If we add in a clone of nothing, then we're going to get that return early. If we add now a clone of an object with A and B, then we're going to get a little bit more code. And so you could actually just use this to learn any specific module, which would be really cool. What I see this being useful in the future is actually integrated into your editor. And so you say, hey, I want to learn this module, and it says, okay, here, like type in your usages, or you have unit tests, and it'll determine, okay, based off of your unit tests, here are the pieces that are relevant based off of this unit test. Here's the code that's relevant for that. You hit next, next, next as you learn these different pieces of the code. So that is one use case, which I think is probably the most compelling and realistic use case of SliceJS. This next one is a little bit of a pipe dream, but I think that it's totally possible as well. And that is this idea of tree shaking. Or it's ultra tree shaking. So it's like tree shaking, but it's even better because you can shake more. So let's just give a quick rundown of what tree shaking even is. It's this great concept from Rollup that Webpack has adopted. But if we have this math module, we have doMath and sayMath that we're exporting these functions. SayMath is this useless function that just represents the fact that I got tired of making examples of useless code. But this do math is sort of handy. It allows you to pass in two numbers and an operation as a string, and it's just this big switch statement with a bunch of cases and stuff. So if we were to do what's called tree shaking, then Webpack or Rollup would go through all of our imports and exports, and based off of those, it knows, oh, nowhere in this application are we actually importing the sayMath function, so we can just get rid of that export altogether, and then ultimately Uglify will come in and remove that function definition. So what you're left with for that module is effectively this, just the do math. So you saved a couple of lines, which is great. With SliceJS, we could take it even further, and SliceJS is totally capable of doing this today. Because we're only calling it with multiply, the code path is, okay, operation, skip that, and run this. And it never actually runs the default, and never runs any of these. And because those functions are never run, those functions are also removed, and all we get left with is the multiply function. And so that's actually a really, really great use case. It's really powerful. Imagine doing something like that with Lodash, jQuery, or React, these really big libraries that like you're sending down to the browser, and it makes your users wait forever. So like I said, that's kind of a pipe dream. The reason for that is because there are so many edge cases handled in these various libraries that collecting accurate code coverage to know what parts of these libraries to slice out would be pretty challenging. Like, you'd probably slice out a bunch of Internet Explorer edge cases or something like that. And if you don't care about those, like maybe you're only supporting the latest and greatest browsers, then maybe that's a good thing for you. But you'd have to take every single permutation that matters to you and have tests for everything, which would be awesome, but not entirely realistic. But I do see this being useful in creating like a custom build for a library or something like that. You say, okay, Lodash, here are my use cases for you. I'm just going to call you with these couple of things. Now give me the slice that matters for those use cases. And now you have a custom build of Lodash that can only support maybe get and map, or pluck, those kind of things. And even though it can only support those things, those are the only things you really care about using in your application, and so you're fine with that. So I see that being really useful in that kind of scenario. To take this a step even further is something that I made up called shaking data. And so I'm not aware of anything that's able to instrument data for coverage, so whether or not properties have been accessed. But we could totally build something like that with JavaScript, and then we could slice out the data that's not being used. So here's an example. We have this log module. It has log, set current level, and log levels with some data in here for those things. And the only thing that we're actually using all of the exports, but from the log levels, we're only using error and warn. And so because these other things aren't being referenced anywhere else in the application, then we would get the same result if we were just to remove those entirely. In this example, you're not saving a whole lot because it's just a couple of characters. And so like you're not going to save a lot sending that to the browser. It's also like not a lot of data, so you're not saving a lot of memory. But let's say that you're doing a localization thing, or maybe something like Moment.js, which has like enormous amount of localization stuff. If you could slice out the data that is only relevant to your application, that could be a really significant savings, not only on the amount of code that you're sending to the browser, but also the memory that's required for that code to actually run. So yeah, that's kind of another fun idea. Again, the biggest challenge with both slicing out data and slicing out code and actually shipping that to a browser is making sure that the slice that you're sending to the browser supports all the use cases that browser needs. This would sort of apply in Node as well to save on memory and stuff, but mostly this is useful for browsers. So yeah, I think that these are some really neat ideas, and I expect that we'll be able to do something like that with SliceJS. So look forward to that in the future. yeah, and this is the demo app. I'll just show you a couple other things that are kind of interesting. So if we scroll down here, there are a couple things that SliceJS does to make sure that the slice is accurate. So first off, if the slice is a correct slice, then you should be able to take this usage of the module and apply it to the sliced version of the module, and you'll get 100% code coverage. That means that there's nothing more to slice out. And in addition to that, here we're returning those usages. What you've returned here should be the same for the original code as it is for the slice. And if it's not, then your slice is incorrect. And I can actually simulate that with a bug that there is in Slice right now by just passing an array, an empty array here. The reason for that is we're calling item.forEach. And if we look up at here, that forEach is actually a function, right? It's somewhere around here. It's inside of, yeah, here we go. It's right here. But because this function is never called, SliceJS removes the function entirely, and then the code breaks. So there are some more edge cases to be dealt with. But SliceJS can verify that and say, hey, there's something wrong here. The original result was this. The slice result is nothing because there was an error thrown. So you need to fix something. I'm not going to slice this for you. One other thing that I didn't mention, or I mentioned I would talk about a little bit later, is here if I add a clone hi, that string, then you're going to have this object prototype toString call item. So we're not actually assigning that to any variable. And the reason for that is, well, up here we were assigning it to a variable and then using that variable. Because that variable wasn't in use anywhere, we could remove it and get rid of the variable declaration altogether. But we can't with confidence remove any function calls because those functions could actually do side effects and things. And so I imagine there's some optimizations that we could do for that as well, because this function call in particular doesn't do any side effects, so we don't need to worry about that. So anyway, that's just a couple of the ideas that I have. Like the original idea came from a talk that I watched at Strange Loop last September by Alan Shreve. It was really, really, really good. It was inspiring, and it taught me about this concept called program slicing. So I recommend you check that out. ASTExplorer.net would totally not be possible without, or like this project would not be nearly as easy without ASTExplorer.net. So I recommend you go check that out. It's really cool. The SliceJS is a Babel plugin essentially, and so it uses ASTs to remove things in a safe way. And then the Babel handbook by James Kyle, really useful. So thank you, James. That's it for me. So feel free to ask me questions in the chat in Slack. And also, this is a link to my slides. This is a link to feedback for my talk. So if you want to submit feedback, I'd really appreciate it. And yeah, I think I've got a minute or two for questions. So if anybody has any questions, feel free. I am here for that.